Hello, I am coming to you with my fashionable Christmas sweater on. We are on the other side of page 24 talking about composite figures, which remember are figures that are composed of many different shapes. This the last one was about when we have a grid and last one was about when we have a grid and we can count the squares. This time we're going to talk about the much more common setup, which is we don't have a grid and we need to calculate the area just like we would calculate the area of a triangle or a trapezoid or a rectangle. So let's say we're going to put carpet down in this room that has a little bit of a funny shape. So there's a wall here, and then there's a hallway, and we're going to put carpet down through the end of the hallway. Okay? It doesn't matter that this is exactly, you just get this general idea. So I don't have a name for that shape. That's looks like a square shoe, maybe. So I don't have a formula for the area of that shape. So I'm going to start to put in some, let's say that this is 18 feet and the hallway is 3 feet wide and this is 5 feet. We have, let's say this looks like 10 feet, and over here this is 8 feet. Okay? Now, the way that I find the area of composite figures is I decompose them. So, composite means created, put together. In order to find the area, I decompose. I do the opposite of composing, which means I'm going to split these apart. I can do this in a couple of different ways. There's no one right way to decompose. So one thing I could do is I could divide, and now I have like shape A and shape B. And then I find the area of both of those figures and I add it together. So shape A is, and this is where you have to be careful at looking at the right measurements, because this whole side is 8 feet, but this rectangle right here is only 5 by 10 feet. So this has an area of 50 square feet. And then I look at B. Again, be careful what you look at. I have 3 feet by 18 feet. Is that 30, 54? And then, of course, I'm putting carpet down the whole thing. I need to add these together. So 50 plus 54 equals 104 square feet of carpet that I'm going to need. All right? Now, just to show you that that's not the only way to do it, try to draw that same figure similarly. Doesn't have to be perfect. All right, and same measurements. Okay, and let's say this time I'm going to divide it like this. So I have, this is shape A, and this is shape B. Shape A, now, you got to be careful, we're looking at the right numbers, but is 8 feet by 10 feet. 8 times 10 is 80 square feet. Shape B, this is where I have to get a little tricky, because I know it's 3 feet, but I got to figure out the base, and it's not all 18 feet, right? The whole thing was 18 feet, but we don't have a number on this side. Now, whenever you get one of these, you can always figure it out by putting pieces together. So if this whole side is 18 feet and this much of it is 10 feet, which I know from up here, then this must be 18 feet minus 10 feet. This piece must be 8 feet. So this is going to be 8 by 3, which is 24 square feet. I add those together, 80 plus 24. What do you know? I get 104 square feet again. So the main thing that you need to remember is that whenever you have a composite figure, you solve that by decomposing, breaking it into smaller shapes and finding the area of those.